On number 7, we're deriving a multiple angle formula. So I don't have a formula for sine of 3x. If you look at your double angle identities, you only have a formula for sine 2x. So what I'm going to do is I'm going to think of this as sine of 2x plus 1x, because that would be the same thing as sine of 3x. Well, now I can use a sum formula and split this up into sine of 2x cosine x plus cosine 2x sine x. So now I have a sine 2x, and I can break that down into 2 sine x cosine x, and that's just my double angle formula here. All right, sine 2 sine x cosine x. And then I have the cosine x. Same thing with the cosine 2x. I can split that up into 1 minus 2 sine squared x and then times sine x. Now, I could have chosen a different one. There are multiple to choose for your double angle cosine. The reason I chose the 1 minus 2 sine squared theta is because I noticed that I'm getting down to like all sines or all cosines, and so I chose to go with trying to get everything down to all sines. And I put this in parentheses because it's cosine 2x times sine x, and when I replaced the cosine 2x, I got two separate things. So I'm going to go ahead and simplify this. I've got 2 sine x, and then cosine x times cosine x is cosine squared x. And then I'm going to distribute the sine x, so that gives me sine x, and then minus 2 sine cubed x. So I notice that I have this cosine squared x, and again, I'm trying to get down to all sines, so I'm going to replace it with my Pythagorean identity, 1 minus sine squared x. Then I still have the plus sine x minus 2 sine cubed x. Then you need to distribute here, so 2 sine x times 1 is 2 sine x. 2 sine x times a negative sine squared is negative 2 sine cubed x. And then I have my plus sine x minus 2 sine cubed x. Now that I have all signs, I'm going to combine like terms. So I got a 2 sine x and a 1 sine x, which makes 3 sine x. And a negative 2 sine cubed x and a negative 2 sine cubed x, which makes negative 4 sine cubed x. All right, so now I'm going to be verifying these. Going to verify that the left-hand side is equal to the right-hand side. So I noticed that this looks an awful lot like the double angle identity, cosine squared theta minus sine squared theta. The only difference is that this is 2a is what represents your theta. So if you look at that formula, whenever this is 2 theta, then this is just theta. So this angle is doubled over here. Same thing here. If this is theta, this is going to be 2 theta. So in my formula, I see that I have 2 alpha, or 2a, so that means that I will double that, and cosine squared 2a minus sine squared 2a is cosine 4a, and that's because I'm taking this that represents my angle, and I am doubling it out here. That now equals the other side, and I've verified that that is true. Okay, so on this one, I'm verifying that this side is equal to cosine 2x. Well, I can't do anything with the sine to the fourth x's by rewriting them in any way, or the cosine to the fourth x. So I look at this and I see that I have the difference of two squares. So I'm going to go ahead and factor this. I know I have a positive and a negative. Square root the cosine to the fourth, and you get cosine squared x. That goes in the front. And then square root the sine to the fourth, which gives me sine squared x. So I've split this apart, and I know that cosine squared x plus sine squared x is equal to 1. And I know that because it's one of my Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. So I've replaced this with 1 times cosine squared x minus sine squared x. That is cosine 2x. And 1 times cosine 2x is cosine 2x, which is the same as the other side, and I'm finished. Now let's talk about our power reducing formulas. So if I have a sine squared, a cosine squared, or a tangent squared, I can replace them with 1 minus cosine 2u over 2, 1 plus cosine 2u over 2, or 1 minus cosine 2u over 1 plus cosine 2u. Notice that if this is u, this is going to be doubled over here. Same thing here, same thing here. All right, so this is one I want to get down to all powers of 1 and all cosines. Notice that all of these involve my cosine double angles. So we're going to take sine to the fourth and rewrite it as first powers of cosines of multiple angles. So in the end, I know I'm done when I get to all powers of 1 and all cosines. So let's start by saying, okay, well, I can't have sine to the fourth x. I can't power reduce that. But I know that sine to the fourth x is the same thing as sine squared x times sine squared x. And I can power reduce those. So I'm going to take that sine squared x and replace it with the 1 minus cosine 2x over 2. And same thing with this one, 1 minus cosine 2x over 2. From here, it's just a matter of simplifying and rewriting until we get to all cosines to the first power. All right, so we have to multiply these two together. 1 times 1 is 1. 1 times negative cosine 2x is negative cosine 2x. Negative cosine 2x times 1 is negative cosine 2x. And negative cosine 2x times a negative cosine 2x is a positive cosine squared 2x. Multiply your bottoms. 2 times 2 is 4. Now, when everything's all over the same denominator, we're going to pull that out. So instead of dividing by 4, we'll show that we are multiplying by 1/4. So I know that inside, this is all I have left that is on the top here. So 1 minus cosine 2x. Notice that cosine has a power of 1, so I will leave it. And actually, I can combine these two. I have a negative cosine 2x and a negative cosine 2x, which makes negative 2 cosine 2x. But this one has a squared, so I need to power reduce that. So if I power reduce the cosine squared 2x, remember, you have to double this for the formula. So that gives me 1 plus cosine 4x over 2. And remember, I'm getting that from my power reducing formulas right here. All right, so I have 1 plus cosine 2u. It's doubled what is in here when it's the squared term. All right, so I noticed that this is over 2, but these are not. So I'm going to get a common denominator of 2 so that I can put some things together. So I will go through and multiply every term by 2 over 2. Now remember, these are in the numerator, so if it helps you, make sure that you write these next to the numerator. All right, then I've got minus 2 cosine 2x times 2 over 2 plus, and then I'm going to go ahead and split this up into two fractions here. So I have 1 over 2 plus cosine 4x over 2. Now there is no reason for me to multiply this by 2 over 2 because I already have a denominator of 2. So now I'm just going to multiply. 1 times 2 over 2 is 2 over 2 minus, and remember this is on top of 1, so I just multiply top and bottom. Negative 2 cosine 2x times 2 is negative 4 cosine 2x over 2. Then I have plus the 1/2 plus cosine 4x over 2. Now everything is over 2, so I'm going to take out a half. So if I take out a half, that'd be 1/2 times 1/4, which is 1/8. And then I'm going to be combining like terms on the top, so I know I have a 2 and a 1. That makes 3. And then I have a cosine 2x, but no other cosine 2x, so minus 4 cosine 2x, and then plus the cosine 4x. Now I've written this. The only trig function I have is cosine, and all the powers are 1. So in number 11, I'm looking here. I already have the sine squared, so I can power reduce that, and I'm going to view the cosine to the fourth as cosine squared x times cosine squared x. And I need to replace all three of those with their power reducing formula. So 1 minus cosine 2x over 2, 1 plus cosine 2x over 2, and 1 plus cosine 2x over 2. So don't try to multiply all three of these at the same time. Do the first two and then take what you get there times the third. So 1 times 1 is 1. 1 times cosine 2x is cosine 2x. Negative cosine 2x times 1 is negative cosine 2x. And negative cosine 2x times a positive cosine 2x is negative cosine squared 2x. All over 2 times 2 is 4. So my middle terms are opposites, so they will cancel. And now I have 1 minus cosine squared 2x over 4. And I will take that times the third one. So if I do the tops, 1 times 1 is 1. 1 times cosine 2x is cosine 2x. Negative cosine squared 2x times 1 is negative cosine squared 2x. And negative cosine squared 2x times a positive cosine 2x is negative cosine to the third 2x. All over 4 times 2 is 8. Now I don't want the 8 on the bottom of all this, so I will take it out and multiply by 1/8 instead. Now I'm going to need to power reduce here, and I'm going to need to power reduce here. The problem is I can't power reduce a cube, so we actually need to view this as cosine squared 2x times cosine 2x. All right, and we need to remember that there is a negative in front of that. So when I power reduce here, the cosine 2x is fine, but I have minus, and then I'm going to replace the cosine squared 2x with 1 plus cosine 4x over 2. Remember, if this is a 2x, you need to double it right here. Minus, and then I need to replace this cosine squared 2x again with 1 plus cosine 4x over 2 times the cosine 2x. I don't need to power reduce that because it already has a power of 1. So I'm going to distribute these negatives, And at the same time, I'm actually going to go ahead and get a common denominator of 2 over here. So if I were to take the 1 times 2 over 2, that would give me 2 over 2. And if I take cosine 2x times 2, that's 2 cosine 2x over 2. Distribute that negative just to the top, so I get plus negative 1 over 2 minus cosine 4x over 2. Same thing over here, minus 1 half minus cosine 4x over 2. Now here's something that you need to remember is both of these were in this parenthesis, so I'm going to make this plus a negative. And I have to take those times this cosine 2x. All right, so that's going to get distributed to these tops right here. So I'm going to go ahead and take out a half, which makes 1 over 16. So inside I have 2 plus 2 cosine 2x minus 1 minus cosine 4x, and then distribute here, minus cosine 2x minus cosine 4x times cosine 2x. Now I have nothing else to power reduce. I'm going to combine my like terms. So I have 1/16 out front. 2 and negative 1 make 1. I have a positive 2 cosine 2x and a negative cosine 2x, which makes a positive cosine 2x. I only have this one negative cosine 4x, and then the minus cosine 4x cosine 2x. Lastly, let's talk about our half angle formulas. So if I have sine of u over 2, it will not be written as this. It will be written as like sine of 360. And if I do sine of 360, in that spot that represents some angle divided by 2. All right, so I would actually have to double this angle when I plug into the formula, because this represents the angle before it was divided by 2. So keep that in mind. So my half angle formulas are listed here. Tangent actually has 2 of them. I usually use this one right here, but you can use this one as well. So first thing you want to do is identify what quadrant you're in. 105, that is in quadrant 2 somewhere. And the reason we need that information is because if I'm doing sine, I have a positive and a negative option for that root. If I'm in quadrant 2, I know that sine is positive in quadrant 2, so I'll have a positive root. But if it was in like quadrant 3, then sine would be negative, so I would have a negative root. Then I'm actually going to figure out what my angle was before I divided it by 2. So this represents some angle divided by 2. So I would double it, which gives me 210. So that's the number I will be putting into my formula. So I've got sine of 105 is equal to the positive square root of 1 minus cosine of 210 over 2. So first, I need to figure out what the cosine of 210 is. So pull up my unit circle. 210, the cosine is the y value, so that's negative 1/2. So I'm going to replace cosine 210 with its value of negative 1/2. Now from this point, you can plug in just the part under the root. Don't plug in the root, but you can plug in this whole fraction. It will simplify that for you, and you end up with the square root of 3 plus 2 over 4. Now, I don't particularly like the square root being in the front, so I'm going to fix that in my answer. You cannot put the square root in the calculator. It will give you a decimal. So you will square root the top, which is 2 plus the square root of 3. And then you will square root that bottom. The square root of 4 is 2, and that is your answer. So on number 13, we're actually going to do the sine, cosine, and tangent of the 165. So first things first, I'm going to decide where 165 is located. That is in quadrant 2. So in quadrant 2, sine is positive, cosine is negative, and tangent, it doesn't matter what tangent is. All right, so I know that when I do my half angle, the sine will have a positive root, but the cosine will have a negative. All right, and then I'm going to double this. So 165 doubled is 330. So I start with sine of 165 is equal to the positive square root of 1 minus cosine of 330 all over 2. I'm going to do the same thing before I move on. I'm just going to do cosine as well since their formulas are very similar. It will be a negative square root of 1 plus cosine 330. That's the only difference is the positive and the negative. So I'm going to replace the cosine 330 with its actual value. So I go to my unit circle, 330. The cosine of 330 is the x value, so square root of 3 over 2. All over 2. Same thing over here, but this would be 1 plus the square root of 3 over 2 over 2. I'm going to put that in my calculator without the root, and that's going to give me 2 minus the square root of 3 over 4. And then I will split that by hand. So I have the square root of 2 minus the square root of 3 over square root of 4, 2. And then for the cosine, I have a negative. I'll put this in. That gives me 2 plus the square root of 3 over 4. So I square root the top, 2 plus the square root of 3, and then on bottom square root of 4 is 2. So there's sine and cosine. Then I'll do the same thing with my tangent of 165. I'm going to use this top one, the 1 minus cosine theta over sine theta. So I have 1 minus cosine of 330 over sine of 330. 1 minus cosine of 330, which we already found was the square root of 3 over 2. Sine of 330 is negative 1/2. And you can plug that in your calculator. So tangent of 165 is equal to negative 2 plus the square root of 3. And I need to go back and make a correction on number 12. Instead of doing cosine, I did sine right here. This is still correct because I already had that written down, but the cosine value is the x, which is negative square root of 3 over 2. So the answer is still correct because I already had that on the paper, but I needed to make that correction.